أعوذ بالله السميع العليم من الشيطان الرجيم بسم الله الرحمن الرحيم الحمد لله والصلاة والسلام على رسول الله صلى الله عليه وسلم وبعد السلام عليكم ورحمة الله وبركاته. Dear viewer of Salam TV, I want to take this opportunity to thank Allah subhanahu wa ta'ala for giving us the opportunity to be still alive so that we can be able to increase on our good deeds and perhaps also be able to reduce on our bad deeds by making tawbah and istighfar. It is Thursday, the fifth day of Jamadu Thani, 1445, that is coinciding with 18th December 2023. In this program of Alhidaayah, we focus much on science and technology in the perspective of Islam, and we have run a number of programs to do with Quran and science. And if for somebody who could have missed some of this series, you can go to our Salam TV channel, YouTube channel, and be able to catch up with whatever you could have missed. In this evening, we are going to continue with yet another kind of a topic, inshallah ta'ala. And in the studio, I'm not alone. I'm with my brother, Sekal Hamza, who is the lecturer at Islamic University in Uganda, and we will be going together with you in this program. Allow me to invite him to say salam, then I will be introducing the topic this evening, inshallah.
Assalamu alaikum wa rahmatullahi wa barakatuh. We thank Allah subhanahu wa ta'ala for the gift of life and the fact that we are here to discuss issues of knowledge, issues of remembering the signs of Allah within our lives. Today we are focusing on issues of medical technology that saves lives. That one is something that is critical, and we hope we shall be able to benefit one another in that particular arena, inshallah.
Inshallah ta'ala. Yes, as hinted on, this evening we are going to start another kind of topic to do with medical science, and we shall have also an opportunity to dig deeper into this. Your brother Menya Ayubu Kibedi this evening to be organizing and introducing you this program. And just before we get deeper into this program, I just wanted to mention that just like we have always echoed, the essence of this program is to inspire you, the Muslim community, and the entire community at large, that we need to invest much in science in terms of the time, in terms of the resources, and even getting the interest to go deeper into science and technology, because it is what drastically changes the lives of the people. Any innovation within science and technology, it can affect quite a number of people, and it is usually intended to benefit people so that they can live better. So when we talk about innovations, we have an injunction from the Islamic perspective that if we are going medical, whoever is able to save a life of an individual, it's as if he has saved the entire humanity. And likewise, if we are to talk about somebody being a suburb, being a cause for somebody to lose life, it is it's the same vein that you have caused almost the entire kind of nation to perish. So against that kind of background, we are bringing this in that spirit, that perhaps if we get inquisitive into investing into this kind of innovation, it can help us to save a number of lives. So at this moment in time, I want to invite my brother Sekal Hamza to throw a lot more light on the justification as Muslims. Why should we be bothered? Because maybe we see that already the science and technology that we have is quite developed. Maybe we can pay aloof to what we have already as being, enough. Why should we have a lot more kind of innovation, a lot more research to do with science and technology, especially in the medical field?
Alhamdulillah, salatu wassalamu ala rasulillah sallallahu alaihi wasallam. Now, one of the maqasid Sharia, a very important one, which are the objectives of why we have all these guidelines within the Sharia, is the issue of protecting life. And in so, Allah subhanahu wa ta'ala has indicated in Surah Al-Ma'idah, verse 32, when he says, min ajli dhalika katabna ala bani Israel. The ayah refers to the Bani Israel, but the laws of Allah essentially cut across all generations. Min ajli dhalika katabna ala bani Israel annahu man qatala nafsan bighayri nafsin aw fasadin fil ardi faka'annama qatala an-nasa jami'a. Whosoever causes the death of just an individual without justification, because the Sharia allows for things like the killing of a person that has killed another, meaning it is not true that the life is protected absolutely. There are certain events that cause life to need to be taken. So one that causes the death of an individual without just cause is referred to or compared with the one that causes the death of all humanity. That's the weight that Allah subhanahu wa ta'ala attaches to the issue of life. Then وَمَنْ أَحْيَاهَا فَكَأَنَّمَا أَحْيَا النَّاسَ جَمِيعًا. And whosoever is able to save, to give life, or to protect just one life, that person is as if he has protected the whole of mankind. So therefore, any innovations in the area of health that improve the chances of people being able to live life, either quality life or to be able to survive some particular diseases or ailments, that one is something that is very important. In a country like Uganda, we have a high, for example, maternal mortality rate, something that our wives, our sisters do as part of their essence as women. They end up dying because of just simple excuses like in the absence of medical staff or just simple medications that may not be available. A person ends up losing their life, yet they are actually doing what has been naturally designed for them to do. So we are going to be looking at some technologies that have been invented. Of course, some of them may not be available here, but the essence is inspiration. The technology may not be here, but it can be acquired, or it can be thought of and implemented within our current means for as long as we have the inspiration to focus. So the very first thing is about predictive medical diagnosis software. Now what happens, the biggest part of medicine is about diagnosis. The treatment part can be done by essentially anyone. Because for as long as you know that it is malaria, the assortment of malaria drugs is already very well known. But the trick is, how do you actually come to the conclusion that this person now has malaria? That is where the whole game is. So the innovation in this case, therefore, is to use computers and their ability to run predictions in order to help the physician, the one that is doing the diagnosis, to come to a more accurate conclusion. So how does it work? We essentially gather information from people, a lot of data, because the predictive computer technologies all work by basing on a history in order to predict the future via data. So if I am, for example, looking at people that have come up with cancer, and I collect information about what they eat, where they stay, their common transportation means, their times of waking up and sleeping, and I have all that for nearly 5-10 years. If a new person comes, this computer can be able to compare the profile of this person that we are going to diagnose with an already existing data set. So that can give you a chance to already suspect more accurately what this person is actually suffering from. So in that case, you don't need to run very many tests, because in some cases, in order for you to come to a conclusion, you have a suspicion, then you run a test. But remember, tests are also sometimes expensive. So each time you make a new suspicion and you run a test, you are increasing the cost of the treatment. Yet, in case you have these predictive medical diagnosis technologies, they should be able to help you to zero down faster on the problem. You may find, for example, cancer people are not belonging to a certain blood group or it is. So the computer will do some elimination before it gives you a more accurate starting point in your diagnosis. That technology is already there, and it is essentially helping out in improving the accuracy of diagnosis. Any inaccurate diagnosis increases the chance of that person being at least injured by that ailment. A person that has got malaria and has spent an additional day with that malaria suffers an additional risk, and also suffers additional damage to the body, because the reason as to why you get sick is that the body is essentially not operating in its normal form, and therefore we end up suffering.
And actually, because when you have a poorly diagnosed kind of person, you will end up getting a wrong medication.
Yeah,
and as we know, the medication that we get, it is toxic in our body.
It also has.
If it is in the body and it has gone there, you know, on an idle kind of reason, then it will affect again. Yeah.
So meaning we only accommodate the medications, their side effects, because of the bigger objective of eliminating the ailment.
Yeah.
But if now the ailment is not actually there, the conclusion has been made that you have malaria. And actually here in Uganda, in case you are having malaria-like symptoms and they test and you are not having the MPs, many times they still give you the
the medics will say that there is clinical malaria. Is what they call clinical.
So meaning any technology that improves the accuracy of diagnosis is something that adds to our chances of saving a life in case we are treating, and that is one area where software has come in, and it is doing a lot of very good work for us in that domain. The second one is using artificial intelligence in radiology. Now radiology, essentially you are talking of either scanning, and here we look at it mainly in the area of cancer treatment, because it's the main disease that tends to be dealt with radio waves. Now, one with cancer, it is diagnosis. How do you conclude that this person is having cancer?
And if it is cancer, where exactly?
Exactly, where, what is the extent? These are all questions that you have to answer if you are going to address a person's cancer very accurately. So what we are now seeing coming up is the use of artificial intelligence in this particular area. So how does artificial intelligence now help here? We human beings essentially also do image interpretation in case we are doing diagnosis, because usually you take an x-ray and the doctor will look at it. So meaning from that point onwards, you are essentially relying on this person's ability to interpret this picture and make the correct conclusion. So what if we can instead replace this human effort with artificial intelligence? Because the artificial intelligence system has access to a very large data set from which it can make a conclusion. Because you may suspect that it is cancer, yet in actual sense it is something else, just because of your ability to interpret that image the way it is at that point. I've seen
many cases where somebody goes to a CT scan, is given, you know, those results. You take to a doctor, gives you his interpretation,
because it has an
but it could not work out well, and you take that very result to another kind of doctor, and they say no, this is something, the problem is here. So meaning the ability to interpret is very critical.
So here the idea is, let's rely on some artificial intelligence. The computer is given a very large set of pictures that show a healthy and an unhealthy chest area. So in case we are running scans and etc., in that case the computer is more able to distinguish based on that very large data set. Because even this experience of diagnosis, the doctors usually gain a better way of diagnosis because of the number of patients they have worked on. Because you'll make a mistake on this one and you'll learn out of it, you know. So the experience builds the human being's capacity to more accurately diagnose. Same thing happens with the computers. It has large data sets of images and etc. that it can use to train itself. So by the time you bring your image of the chest area or any area that is suspected to be having, it already has the elimination that is needed to come up with a very accurate conclusion. And they are also talking here of even segmentation. Like you said, yes, there is cancer, but where? And to what extent? And in case you are going to be treating, how much of radiation should you apply and etc. All these decisions are essentially manually done for today. And there is also an understanding that radiologists are usually very few. It is an area that is not very well attended to. So you'll find there are usually a few people that work in that area. You'll find just 1, 2, 3 people. So in that case, you really have to rely on just that one individual. But if you can allow software systems like artificial intelligence to also venture into this area and help us to deal with this radio element, then in that case we are able to benefit out of it.
Yes, Brother Hamza, we are going for a short commercial break, but there is something that you have talked about to do with artificial intelligence for the benefit of my viewer. Somebody could be hearing it for the very first time, talking about AI.
Okay.
So maybe when we come back from this short commercial break, you formulate a bit. What is it about artificial intelligence and how it is leading to that kind of innovation, inshallah.
Okay.
Yes, Salam TV.
Friends, you may not believe this, but Uganda is actually running out of trees. So we have a campaign. We've partnered with several leading corporates to plant more trees. Our ambition is to plant 40 million trees in the next 5 years. We've done quite a lot of that. Stanbic alone in the last year planted 70,000 trees. And when we do plant these trees, we're not just planting, we are growing the trees. And we're very deliberate about how we're doing this.
At Uganda Breweries, we have a vision called Society 2030. Our dream is that every Ugandan would plant a tree and maintain it by the year 2030.
Stanbic coming on board as cutting across, and through Stanbic we've had a number of other players actually coming through because of our engagement with Stanbic. They've committed budgets to do actual planting, because the Roots campaign is designed in a way that the partners are at liberty to decide which way they do their participation.
We believe in Uganda.
You can touch this. Hey, but you can test it. Ooh, but you can test it. Everybody grab a bottle and sip some. It's Mirinda time, flavors and much. Tongue tingling, thirst quenching and bombastic. Oh, sweeter than sweet, bolder than bold. Flavors explode, making you go oh, you can test it.
There's no flavor like Mirinda, now in a fresh new look with the same great taste. Enjoy the tongue-tingling flavor of Mirinda Fruity, Orange, Green Apple, and Pineapple. Mirinda.
Meet Stone Atwine, the co-founder of Eversend, a startup that is building financial technology from Uganda to the world. From currency exchange to business banking, Stone and his team are doing it all. Stone embodies the grit and the commitment to take a startup from nothing to something. Stone, Keep building. You are unstoppable. MTN, the Unstoppable Network, celebrates you. Download the Eversend app or visit eversend.com, and together, let's support Ugandans like Stone who are driving our country's unstoppable progress.
Eno ye Salam TV.
Okay, dear viewer, I want to welcome you back from that kind of short commercial break. As we concluded the first, 30 minutes, we were talking about how AI has really, made a contribution in making predictions and interpretation of medical results, and it helps the medics to be able to give you the accurate kind of result, as opposed to when somebody is using the naked eyes and using the experience gathered. As we know, experience, it comes with years. So meaning, if you want that kind of experience, you always go to somebody who has been practicing for the past maybe 20, 30 years, which is usually not the case when it comes to our hospitals, clinics, and the like. So it means there is, a need for us to be assisted in one way or the other. So we were talking about AI and how it can help, somebody to give accurate results. So Brother Hamza, as we went for a short commercial break, I was, for the benefit of my viewer, I wanted us to throw more light on the issue of artificial intelligence and how it is affecting this kind of industry.
Okay. Now, when we talk of intelligence within the human realm or within the human domain, we are talking of ability to make correct inference based on information that you are having. So when I see an object X, I should be able to determine whether it is beneficial to me or a danger to me. So that kind of conclusion is what we call intelligence, and it's what separates the human beings from most of the other creatures. Most of the other creatures don't need intelligence, because for them they live a life of instinct. Essentially, when it is born, it has an already predetermined thought process. There's no much of thinking. You are born, simply open your mouth and start looking for anything green and eat it. So in that case, that kind of creature does not need intelligence. It has already well written.
I think maybe for a purpose, again, for a purpose of my viewer is, yes, I can be able to know this thing is either harmful to me or not. Is it an end in itself? At the end of it all, there is a reason as to why when I see this is something X, then I think I need to make a rational decision.
Exactly. That's what we are talking about. Capacity to determine or define objects is what we call intelligence within the human realm. And that's why when a child is born, the child is not able to actually even do what we call seeing, just because at that point the child has like zero intelligence. The only thing it has is the instinct to eat via suckling the mother. And you can see that in that case the child does not need to be taught anything when it comes to breastfeeding. The moment it falls onto the birth area, it begins to eat. In that case it is instinct. But that point forward it has to learn. And it learns by data collection. So when it looks at a certain object, it story by story it builds an understanding, and a time comes when it knows this is now the mother, this is the father, the other one is a fawn.
It sees the mother will cry for the breast,
so it even knows
the father.
Exactly. So it will not cry for the father's breast, but it cries for meaning it has now built an intelligent way of differentiating between these objects, and that is the whole idea about intelligence.
So, dear viewer, what we are trying to say here is that we want to have computers that can help us to make rational decisions based on the data that is available, that has been collected for the past years, as opposed to maybe somebody who is sitting in a clinic and the exposure would not be as that big as what can be fed in a computer.
So what computers help us with, what we're calling artificial intelligence, is that one, for them they are able to consume bigger amounts of data. You can, as a human being, read books, yes, but the computer can read 1 million books in 1 hour. So for it, it's not limited like the human being. If it is image analysis, the computer can load thousands or even billions of images in a very short time. So that advantage that it has over our capacity to consume knowledge gives it an edge when it comes to intelligence that is based on learning. So therefore, what we have built as computer science people is what we call machine learning. Can I give this computer information and build a decision model for it? For example, I want this computer to help me to detect any chest that has some abnormalities in it. So I give it 1 million photos of chests that have no problem. Then I give it another 1 million photos of chests that have problem in them. Then I also feed the algorithm with some corrections. Whenever you see this part bigger than this one, make this conclusion. Whenever you see this part is smaller than this, make this conclusion. So that body of conclusions that comes out of observation is what we call artificial intelligence. Now, because the computer does it very fast, it gives us it has an edge over me, who is a human being. Yes, we may both see a picture and conclude correctly, me versus the computer, but the computer is able to come up with that decision in a microsecond, yet for me I may need some more time to observe. So therefore, if I'm using radiology and I'm employing a computer to help me in analyzing these pictures, for it even has capacity to zoom into an image and make it far bigger than what I'm seeing. All that is the additional advantage that the computer has. Of course, these technologies don't replace the human beings. The human being can never be replaced, because even that algorithm, that mechanism that is making the conclusion still has to be taught by a human being. It has to be moderated by a human being. And that is how it finally ends up being helpful. And as time goes by, it keeps increasing in accuracy. As it consumes more data, it becomes more accurate in the way it works. So that is the whole...
And that is the process of what we call machine learning.
So machine learning is where the computer is now building knowledge, just like the way a child builds knowledge. So all of these ideas are derived from the way we human beings operate. A child learns by observation. Finally, it knows that this thing is a phone. When you press here, it brings new things, and you'll find a small child of 1 year.
A little boy, you try to give a toy, will throw it there and you pick the phone.
Because it knows that this thing has additional advantage. So that is how the child grows, and finally it is able to even manipulate that phone itself, just by gathering information and realizing what each of these things that it is seeing or it is hearing, what it means. That is the whole idea about intelligence. Now, the other area that is boosting our capacity to treat ourselves is the use of quantum computing in the discovery of drugs. Now, you realize that in places like Uganda, we have all this vegetation, and we have a big chance actually of getting medicines out of the herbal system, the trees and all the other vegetation that we already have. But that's not the case in many countries. Uganda is in the equatorial region. We have all this variety of crop cover or vegetation. But in some countries, the only way they can build medicine is through the pharmaceutical system, meaning you artificially create the drug. You don't base on what is already existing in the natural space. Now, what happens is you create the drug by combining a number of chemicals and relating them with the target that you are trying to fight. For example, I have a malaria parasite. It has composition A, B, C, and D. So how do I create a drug that can be able to break down this parasite and it becomes vulnerable to either body defense or it even dies in its entirety? So initially you have to to think of it. You don't start from zero with a test. You have to theorize and say, okay, bacteria X has material A, B, C, and D around it. So in order to decompose this material and make it more vulnerable to being destroyed, I will need chemical A, B, C, and D. But in that case, you have to keep testing out and running a lot of simulations in order to come up with what you think can be a working formula. So initially, they used to do it manually, essentially based on the understanding of chemistry of a human being to come up with what ideas you are having. Then later, computers were employed, but still the process was a bit slow because the chemical processes that are needed to be analyzed are very big. Sometimes the models require a lot of processing capacity for the computer, so it was not also fast enough. But now with the quantum computing,
before you go to quantum computing, just to put it in a more perspective way, we are saying that if somebody, say for example, took poison, so we want to break this chain of poison so that it doesn't harm the body or the person. So we need a kind of chemical component. We have to develop a chemical component that that will dilute and diffuse the poison, so that this person can stay longer even when he took poison. So it is what we are trying to talk about.
So meaning even if it is a disease-causing agent, we are essentially trying to see if I have disease-causing agent X, how can I apply a chemical compound to it that will either make it unable to cause damage. Yes, it's there, but I've covered it with a material that prevents it from causing damage. So slowly by slowly, it just follows a natural cycle and dies and goes off.
Yeah, it's just like now, say for example, when you look at this, when HIV came to Uganda, of course with the kind of theories that we had, witchcraft and the like, until there was research on how somebody can live with the virus, and these days people, even the grueling ones that you see are the ones that are having it. So meaning there has been a lot of kind of research that has been done to make that virus either dormant or being non-reactive and being tameable.
Or you may decide to cut down on its production. So there are different theoretical approaches in which you can fight a disease-causing agent. Either you can encircle it with a material that prevents it from harming the body. So in that case, you leave it. Yes, it is alive, but it is just like any other cell. It's not causing any harm. Or you can destroy it totally. Meaning you apply a chemical agent that will cause that entire organism to simply die off. Or you can reduce on its capacity to reproduce, because you are sure it does not have a very long lifeline. So meaning if you can prevent it from reproducing, you simply have to wait for some little time, and slowly by slowly they will keep dying until finally you don't have. So all of these ways of treatment require a lot of analysis. And quantum computing, which is the next level of very high-speed computing, is helping out in this case. So instead of having models that would require weeks, months to run through in order to come up with an endpoint, you now have computers that can be able to do all these billions and billions of calculations in a very short time. And finally, you have your theoretical understanding of the drug in a very short time. You saw how computers were very effective in this recent scourge of COVID-19. You can see that COVID did not even take a whole year for vaccines to be created. Yet we have this HIV that has been around for, is it how many years? 30, 40 years? It's heading nowhere. Although in Uganda, I think there is some ongoing work which is very good. But you can see that it took a far shorter time for vaccines to be generated for this COVID-19, just because there was a lot of computing power. Things that would require a lot of theorization and running under very complex modeling would now require a far shorter time in order for results to be essentially found.
Just maybe to interject somehow, How is quantum computing related to supercomputers in terms of the processing of...
Now, supercomputers have been around for some time. The only difference here is that we change the entire way in which the computer does its processing. Because the supercomputers, you base on the same way this normal computer works, but you simply give it more power. Then finally you have a faster and a lot more able computer. But in the case of quantum computing, in this case, you are not relying on the normal process of computational power. We don't want to go into a lot of computing theory, but let's just understand that computers simply manipulate the zeros and ones in order to come up with whatever we see, be it an image or a sound or etc. So that is the theory of how it works. But you can change that entire thing and go back to zero and restructure. What if I change the way the computer is actually doing this thinking, and I have greater speed, yet it performs the same role but at a greater speed? That's what we are looking at quantum computing. Then the other issue, I think it may be the final one, is the issue of remote patient monitoring. Now you realize that the doctor gives you drugs, except if you are admitted, but in case you are not admitted, the doctor will give you drugs and send you home with the hope that you will follow the instructions that have been given. But you may either refuse to follow the instructions, or you may forget, or like we said, the diagnosis may not have been accurate. This person is actually having high blood pressure, but it was not seen. Instead, the doctor has diagnosed something related with the headache that the person was feeling, and they thought maybe this headache is being caused by a bacterial infection, so let's give this person this drug. So it means you are left to go home. The only way that doctor can know that he made a mistake and needs to do another diagnosis is when you return, and in that case either you have returned in a good way, or you have returned far worse than the way you came. So the technology that we are now looking at is remote patient monitoring. Now with the remote patient monitoring, you can rely on things like these smart watches or etc. to keep constant update on the patient's condition, because these devices here are able to measure some of the core basics. For example, blood pressure, heart rate, and even oxygen levels. That one can be easily measured just using this smartwatch. So in that case, you are able to, if this watch is connected to the internet and each time it measures, it updates a central monitoring point. Even the temperature can be. You end up being able to monitor and see how this person is progressing. If you, for example, are monitoring blood pressure and you realize that this person, whenever it reaches a time X, the pressure goes up abnormally, then it gives you a chance to have greater insight into how do you diagnose this individual. You are monitoring blood pressure, monitoring blood oxygen. The person may even be living in an environment that has very poor aeration, and it's what is causing all these other effects. Low oxygen level causes some other problems. So in that case, if you can be able to monitor this person continuously and without a lot of effort, because we are not looking at it like police CCTV where you sit there and watch. Here, the systems simply pick the data from the person's body and they keep relaying to an internet-based server. And after that, the doctor can come and do an analysis after maybe 1, 2, 3 hours and see what anomalies are coming in place. So that remote patient monitoring is something that has been developed now, and you'll find it is even being used by insurance company, health insurance companies, in order to improve the way they do an assessment of premiums. Because if I have my Ayub here and I see his vitals are always stable, it means he does not really have much of potential for illness, compared to another that I see he keeps having spikes in their blood pressure or lowering of the oxygen level. It means I can decide to conclude that this one has a higher risk of
so that you charge the premium.
So I can vary the premium in a more accurate way in case I am able to remotely monitor these patients. So that is another very important technology that we have seen coming up. And these are big wearables, but there are others that are very small. Nanotechnology can allow you to fix a very tiny chip inside the person, and they're able to do their work without necessarily having to rely on a big device like this. But even if we just rely on these ones, we should be able to have better monitoring of our health as we live. Now.
Okay, thank you so much. At least so far, with the little that we have been able to cover within those minutes, it is very insightful, and you really see that in the developed world, because some of these have not yet come to our Uganda and Africa, but the hope that we have is that once it is there for the people who can afford, you can be able to to get it. And now, given that the world has become a global village, whatever has been done there, it can be replicated here, but maybe with kind of the Chinese model that you can try to cost manage something, and be, the least developed countries can also be able to benefit from those kind of technologies. So inshallah, we are hoping that with time, even these high-end kind of technologies shall be here, and they will help us in improving the quality of life and the rate at which we are able to diagnose correctly the diseases. So we are coming to the end of this program. I just want to ask Brother Sekalima to say your closing remarks.
Okay, maybe let's just add one before we do the closing remarks, and that one is the area of mental health. You know that Uganda, our mental health index is very bad. They made a study, and they realized that over 30% of us are having some kind of mental health disorders. Problem. So here what we are seeing is that for you to make a conclusion about your mental health, many times you need a mental health expert like a psychiatrist or one of the others to study your behavior and give you a conclusion, and so now you need actually to go for treatment. You have mental health X and Y. Then also, even as because mental health is has a complicated treatment procedure, you require therapy. It's not an instant thing like where you take a drug and tomorrow you are walking around very well. Here you talk of gradual modification of a person's behavior. It means therefore that Ayub may start his treatment today, but as he goes by, we need to be able to help this person even if he's not within the clinic itself. So we are having what we call therapeutic what do they call it, digital therapeutics, that help this individual to do some self-diagnosis before they necessarily sit with the psychiatrist, because already the psychiatrist also bases on a certain model in order to conclude that this one has disorder A, B, C, and D and needs treatment A, B, C, and D. So here you have some mobile apps or some other technologies that help you as an individual to diagnose. They ask you a few questions, make you observe certain objects and etc. And finally, based on what is already well known within the mental health arena, you can be able to determine by yourself that I'm having disorder A, B, and C. So in that case, either when you are on treatment, but you are now awaiting a review maybe during the week, you could damage yourself within the week because the health person is not going to keep looking at you. But if you have these simple tools, the digital tools that can help you to make conclusion about your mental health, then you stand a better chance of avoiding either worsening the situation or even improving in a faster way compared to one that is relying 100% on this health practitioner. So that will be the final technology. We have a number of others, inshallah, we shall be continuing with the same. This entire effort is to see that people have sat down and thought of innovative ways of improving the way we manage our health. And the good thing for most of the technologies we are looking at here, these are essentially technologies that are aided by computers. The advantage of the computer technologies is that primarily we have all capacity. We don't need a lot of investment in terms of equipment. For as long as you have this computer here, then you should be able to build an app, you should be able to program software, and that's why we encourage all of us that are able to access these tools to think of how to implement them, and we see ourselves in a better way, inshallah ta'ala. Assalamu alaikum wa rahmatullahi wa barakatuh.
Wa assalam wa rahmatullahi wa barakatuh. Barakallahu fikum wa jazakumullah khair for giving us time to come to this show and be able to share with us this kind of insights. And we hope that the community that we is supposed to benefit from, you should be able to to at least speak one or two things. If you are not able to appreciate, at least you share with somebody whom you think that would appreciate it better, and progressively we can be able to advance our kind of community to a better level. With that, we come to the end of this program. Until next time, same station. Subhanakallahumma bihamdika ashhadu an la ilaha illa anta astaghfiruka wa atubu ilayk. Assalamu alaikum wa rahmatullahi wa barakatuh.
Eno ye Salam TV adhan ngekutusibwako